teacher from Tui Forest Environmental Education Centre. We've decided to make a little video for you to look at the type of equipment we use when we measure abiotic data. The reason we're doing that is when you come to Tui Forest to do your ecological sampling techniques program, it's going to be expected that you're able to use this equipment to actually measure the abiotic data at our Transect site. So hopefully from this video you'll see some of the equipment we use and how it is used to measure a variety of types of abiotic data. The first bit of equipment I want to show you is what we call a laser rangefinder. A laser rangefinder is a device that we use to measure the canopy height. So it's a very simple device. It points a laser at the top of a tree, and from that we can determine the height of that tree. Now, you might recognize something like this or something similar, which in schools we've used before, which is called an inclinometer. And an inclinometer was an analog device, very simple. You point it at a tree from a certain distance and basically measure the angle that you are looking at from that tree, and then you use trigonometry to actually work out the height of that tree. A laser rangefinder is actually a lot simpler to use, mostly because it does all the maths for you in-house. So this is what we call a laser rangefinder. You might recognize them because they're usually used in movies to show for example, a sniper actually working out the distance to a target. So this will actually measure the distance to a target as well as it measuring the height of a tree. So there's two different functions. We've got the power button, nice and simple. We've also got the mode button. We don't need to use the mode button because it's already set to measuring the height of a tree. What we do need to do is simply turn it on and then point it at a tree. Now, when you point it at a tree, you're going to see some crosshairs, and those crosshairs are what you use to target the topmost leaves of that tree. By pressing the on-off button, simply by pressing it, it will actually measure that height of the tree, and believe it or not, it'll actually show you the trigonometric values that they use to actually measure that height. The great thing is that you don't have to do any maths to actually work it out. It'll simply tell you the height of that tree. Another device that you'll be using when you come out and visit us in Tui Forest is you're going to be using what we call a spherical densiometer. A spherical densiometer is a very, very simple device that's used to measure canopy cover. Canopy cover is basically the amount of foliage that's blocking the sunlight's path to the earth. And basically it's the shade that we see on the ground. The reason we can't measure the shade on the ground is because the sun is never straight above us. It could be on an angle, etc. And we could be, if we measure the shade, measuring the canopy cover that's over there, or over there, wherever the sun is in the sky. So instead we use this device. It's a very simple device because it basically involves a convex mirror that has a grid engraved onto the surface of that mirror. It also has a spirit level, and that's all there is to the device. The spirit level is more or less used to basically make sure that this spherical densiometer is perfectly flat, so that we are making sure we're measuring what is directly above us. When we do this and we hold it, or you can place it on the ground, whatever you'd like to do, we basically look in there and we can actually see a mirror image of what is exactly above us. What we do is we use that grid to work out how much blue sky we can see in the actual grid. I'm going to show you at your schools how to use this device in more detail, because it's a little bit more complicated than that in terms of how we identify where those bits of blue sky are. But put simply, this spherical densiometer is what we use to measure canopy cover. And it is very easy, but once I'm at school I'll show you in more detail how it's used. The final bit of equipment I want to show you is what we call a Vernier LabQuest. Now, a Vernier LabQuest is a data logger. We can use a variety of probes to actually measure a whole range of abiotic conditions. Now, a lot of those are freshwater abiotic factors, which obviously don't really take place up here in the dry sclerophyll forest. But there are a number of probes that you're going to use on the day to measure the abiotic conditions at the Transect site, from down the wet sclerophyll all the way up to the dry sclerophyll. Those probes include something to measure humidity, a probe to measure temperature, a probe to measure soil moisture, and a probe to measure light intensity. Now, we don't have the light intensity one on us right now because this will only allow 3 probes to be used on it at once. But I need to show you how to use each probe separately. So what we're going to do for the remainder of this video is actually show you each of those probes and how we use them. The first probe I want to show you is the thermometer. Now, the thermometer doesn't look like what you expect a thermometer to look like. It actually is more like what you'd see on something like MasterChef, where they measure the temperature of food. This here is a metal cylinder and allows you to measure temperature. Now, the 2 temperatures that you're going to be measuring is firstly air temperature. So air temperature, you just need to wave this thermometer through the air, and it will actually measure the temperature, and you can read that recording on the Lab Quest. Once you've measured the air temperature, which should be the first thing that you measure, you then need to insert this probe into the ground all the way through to the black handle, so that we're measuring entirely the soil temperature as well. If you leave this hanging out of the soil just a little bit, you're actually going to be measuring the air temperature as well. So it needs to be inserted into the ground all the way through, so you cannot see that metal cylinder at all. The second probe you're going to be using is what we call the soil moisture probe. Now again, this needs to go into the soil, and it needs to be inserted into the soil so it is all the way immersed in that soil, all the way up to the black holder at the top. If you don't do that, it won't measure properly. Now the problem with Tui Forest is that Tui Forest has got very, very hard earth, and it's full of rocks. And because of that, where you put both the soil probe and the temperature probe needs to be very, very careful, because you will break them if you try and force them into the earth. The simplest thing is to find some grass. Grass does not like growing anywhere where there are rocks or hard earth, and actually loosens the soil a little bit. So in the end, if you find a bit of grass, you can insert both these probes just below it, and it should work quite well. And again, to measure those abiotic factors, you're simply using the Lab Quest to measure that data. Once that's in the ground, you should be good to go. The third probe you're going to be using is humidity, or measuring relative humidity. Now when you measure relative humidity, it's really important that you do two things. The first thing is that you actually hold this low to the ground. On a day like today, which is a little bit windy, the humidity will be blown away, and it won't accurately measure the humidity that would normally be here. So we hold this low to the ground because moist air is heavier and will actually sit close to the ground, and the wind doesn't necessarily blow that away. But what we do is we make sure that when we measure that, we're actually measuring that recording, okay, when the wind has stopped. The other thing is you need to hold it away from your breath. You hold it away from your breath because you have very, very moist air coming from your mouth, and that can impact your data reading as well. So a few things. Number one, hold this very, very far away from you so that you don't get your breath near it, and hold it low to the ground so you can actually measure that humidity as accurately as possible. The last sensor we need to talk about is our light sensor, or lux meter. This is designed to actually measure the light intensity coming from the sun. Now to use it, we actually have to make sure that the little light sensor at the top of this probe is pointed towards the sun in an area that actually reflects what the quadrat looks like. So you don't want to put this in a shady area if the rest of your quadrat is full of sun, and you don't want to put this in a sunny part where the rest of your quadrat is in shade. So try and find a part of the quadrat that represents the sample as a whole. Now when you do this, you need to, number one, obviously point this towards the sun and read your vernier Lab Quest to see what that reading is. The other trick you need to make sure that this setting on this little box is set to 0 to 150,000 lux. Tui Forest gets a lot of sunlight, so you need to have that on the highest range, so it's measuring across the highest range. If you have this set to anything else, it has a maximum value, for example, of 6,000. All you get in all your sites is 6,000 because all your readings are well over that, and that's the maximum setting it'll read. So make sure in this box that you turn it to 0 to 150,000, hold that towards the sun, measure the light intensity, and that's the last abiotic factor that you'll need to measure with your vernier Lab Quest. The very last test that we need to do is what we call a soil pH test. Now there's a number of ways we can use this. We can actually use an electrode that requires all these buffers, and we can use our vernier Lab Quest to measure that, but it's a little bit problematic and requires a lot of work to get that calibrated or use it well. So instead we use something much simpler for students, which is a soil pH test kit, which is a chemical test. Now to do this, it's a really easy thing to do. The instructions are on the front, so you've just got to follow those stepwise instructions, and you'll find that it is not a hard test to complete in the field. So I'm going to show you how to use that right now. Now this process is fairly simple because all you need to do is follow the instructions on the back of the packet. It tells you everything that you need to do, and as long as you follow that, you cannot go wrong. So we're going to do that right now for you. When you open up the soil pH test kit, there's a number of things that you're going to get. You're obviously going to need the two chemical reagents, okay, which we're going to mix to actually create a color that actually we can use this chart to work out what the pH is. We need a little stirrer so we can actually stir the soil and the chemical, and we need a white tile so we can actually see that color change when we do it. So these things are what we actually need to do this chemical test. The last thing we need is obviously a bit of soil so that we can actually do the soil pH test. So the first thing we need is obviously a soil sample. Now this soil sample is being collected. Any lumps that were in it are being crushed up so it's a nice fine powder, and any debris like sticks and leaves or other organic matter has actually been removed to make sure that all we've got there is the soil. The next thing we need to do is add some of the purple indicator liquid to the soil and mix it together so it creates a paste. Now, as you can see, I've actually made a nice wet paste by mixing in enough drops of that indicator liquid that the dirt is actually now wet and there's actually a color that I can see. The last thing I need to do is add some of the white barium sulfate powder that actually will make that color stand out so I can actually use the chart to work out what the pH is. Now I've dusted the barium powder into that soil and you can actually see that there's a nice green color change. That colored powder is what I'm going to use my pH indicator chart to determine what pH it is. Now for me, according to this chart, I would say that my pH is approximately between 5 and 5.5. So at the moment, by looking at the powder, and it may not come through the video that well, I would imagine that the pH of this soil in particular is probably around 5.5. That's the recording I would be putting in my field booklet if I did this soil pH test in the field. So students, hopefully that gives you some understanding of the way that you're going to measure your abiotic data when you come to visit us at Toohey Forest Environmental Education Centre. On the day, it's going to be a very, very busy day, so the more that you know about how we're going to use this equipment is going to make it easier for you on the day and make it faster for you to gather all the data you need to start making some conclusions about the forest and how the plant species transition from a wet sclerophyll forest to a dry sclerophyll forest. So hopefully you enjoy that, and we look forward to seeing you soon. See ya.